This is lesson 2.3, solving radical equations. So we'll go over the steps to solve radical equations. First, we're going to isolate the radical on one side of the equation. Next, we'll raise each side of the equation to the power of the index to eliminate the radical sign. Then we'll solve the remaining equation. And finally, we'll check for extraneous solutions. So we'll work through a very simple example just to see each step in action. So first, we're going to isolate the radical. So first, we're going to isolate the radical by subtracting 5 on both sides of the equation. Now we're left with the square root of x equals 12 minus 5, which is 7. Then we're going to raise each side of the equation to the power of the index. Because this is a square root, we're going to raise both sides of the equation to the power of 2. So the square root of x raised to the power of 2 equals 7 raised to the power of 2. Now we'll solve the remaining equation. X is equal to 7 squared, which is 49. Finally, we'll check for extraneous solutions by replacing x with 49. So the original equation, square root of x, which is 49, plus 5 equals 12. Square root of 49 is 7, plus 5 equals 12. 7 plus 5 does equal 12, so we're good. So let's do another example. First, we'll isolate the radical. So we have negative 4th root m equals negative 3, because we're subtracting 3 on both sides. Now, because both of these terms are negative, we can multiply both sides by negative 1 to get rid of this negative. We have the 4th root of m equals positive 3. Then we'll raise each side of the equation to the power of the index. The index here is 4, so we'll raise both sides of the equation to the power of 4. So we have the 4th root of m to the power of 4 equals 3 to the power of 4. These will cancel out, so now we just have m equals 3 to the power of 4, which is 81. Then we'll go back and check by replacing m with 81. So the original equation is 3 minus the 4th root of m, which is 81, should equal 0. So we have 3 minus the 4th root of 81, which is 3, and 3 minus 3 does equal 0. Now let's work through some more examples. We'll go through some examples. So the first example here is the square root of 51 minus y equals y minus 11. The first step is to isolate the radical on one side of the equation. In this instance, it's already done for us. So the second step is to raise the equation to the power of the index. Now the index here of a square root is 2. So we have the square root of 51 minus 5y equals y minus 11. We're going to raise both sides to the power of 2. The squares will cancel out, so we have 51 minus 5y equals y minus 11 times y minus 11. Now in this case, we can't just distribute this exponent to both sides. We'll have to factor, or we'll have to FOIL. This is just a simple FOIL. We'll multiply the first terms and outside terms. So we have y squared, y times y is y squared. Negative 11 times negative 11 is 121. Then we have these terms, negative 11 times y, and y times negative 11. So we'll rewrite this, 51 minus 5y equals y squared minus 22y plus 121. Now we can solve as normal by setting this equation to 0. So we'll take this 51 and subtract 51 on both sides. And we have this term, negative 5y, so we're going to add 5y to both sides. So we have y squared equals, so now we have y squared Negative 22y plus 5y is negative 17y. 121 minus 51 is equal to positive 70, set equal to 0. Once we've reached this point, we can factor this out. Two terms that are going to add up to negative 17 and multiply to positive 70 is negative 10 and negative 7. To find the zeros here, we can set each individual factor set to 0. So what minus 10 equals 0? Positive 10. What minus 7 equals 0? Positive 7. So your possible solutions are positive 10 and positive 7. However, the last step of checking and solving radical equations is to check for extraneous solutions. So we'll have to replace y with 10 and 7 to make sure that these work. So we'll go back to the original equation. Let's test 10 first. Y equals 10. We have the square root of 51 minus 5 times y, which is now 10, equals y, which is 10, minus 11. So the square root of 51 minus 5 times 10 is 50, equals 10 minus 11 is negative 1. So we have the square root of 1 equals negative 1. Now this is not true, so 10 cannot be one of our solutions. Now let's check if y equals 7 can be one of our solutions. So 51 minus 5y, which is 7, is equal to 7 minus 11. 51 minus 5 times 7, which is 35, is equal to negative 4. 51 minus 35 is 16, but the square root of 16 is positive 4, which does not equal negative 4. So for this example, there are no solutions, because while we did factor it and find it, neither of these work. Now for the second example, there are radicals on both sides, so we'll just raise it to the power of 2 on both sides to get rid of these. So x to the power of 9 equals x equals rad x minus 1 raised to the power of 2. This will cancel out. So x plus 9 equals rad x minus 1 times rad x minus 1. Again, doing the FOIL. We can simplify that equation to x minus 2 square root of x plus 1. We can rearrange this equation. So we'll take the x and subtract it on both sides. Minus x minus x. X minus x equals 0. So we have x equals negative 2 square root of x plus 1. This plus 1 will take away on both sides. So now we have 8 equals negative 2 times the square root of x. We'll divide both sides by negative 2. 8 divided by negative 2 is negative 4, equals the square root of x. Then we'll raise both sides of these equations to the power of 2. Negative 4 to the power of x to the power of 2 is equal to x. Negative 4 raised to the power of 2 is 16. So x equals 16. And let's check for extraneous solutions. So the original equation says x plus 9 equals the square root of x minus 1. When x equals 16, we have the square root of 16 minus 9 plus 9 equals the square root of 16 minus 1. 16 plus 9 equals 25. So the square root of 25 is equal to the square root of 16, which is 4, minus 1. Now the square root of 25 is 5, which does not equal to 4 minus 1, which is 3. So again, there's no solution.